Hello everyone. This video continues the last one that we talked about finding the volume of this solid using the disk method. So for the disk method, what we have to remember is the axis of rotation is the one that indicate what element that we have to use for the area that we have identified. Alright, so this one because the axis of rotation is the x-axis. Okay, so this case I have the x-axis right here. X-axis is y equal to 0. And the element has to be perpendicular to the axis of rotation. So in this case, my element will be this. Okay, so it's true. It's perpendicular to the axis of rotation. And what we need to do is, because of the area that we have, it identify our shapes. So this area that you have right here, you rotate this about the x-axis, and with so many revolutions, so many disks here, it forms this shape that we have to find the volumes for. Okay, so let me show you the next page. Okay, if we are going to have a face-to-face class, I would pass the solid around for everyone to view. However, because we have to take this course online, so I have to take a picture of this shape, and then I show everyone on this image right here. So I hope that everyone can visualize the shape that we are talking about. Okay, so I think the image is pretty clear in this case. So this is the half size of this, so we can see the cross section of the solid. And this is the four solids right here. And this image is more like upside down, so you can see that this is the parabola here. This is your parabola, all right? And rotate about the x-axis. That means we are forming another parabola. And then this is half the solid. This is the solid. So if you take a look at from the top view, you can see that this is the cross-section area that we are talking about. Okay, so this is the circle here. It's formed so many disks. And then if you take the sum of all of this all together, you are forming this solid. Okay, so I would like everyone to take a look at this. All right, so take a look at this that I'm going to draw for everyone. I'm going to draw a line through here. So this is the function that we are talking about. Okay, so this function is y equal to 9 over x. Okay, so keep that in mind. I go back to our example. Okay, so our example, and when I identify this for everyone, I said that you have to use these formulas, right? Volume equal to pi times integral from a to b of y squared dx. So y squared is a function in terms of x. So take a look at this. You have y equal to 9 divided by x squared. So go back to that. I am going to show everyone that we are going to use a volume equal to pi integral from a to b of 9 over x, all of it squared times dx. So now you see your integrand match exactly what you have to find. Here is your differential factor dx. Your function is in terms of x, 9 over x. And what about a and b? Because finding dx, it means that you are going to get the two values on your x-axis. So where are those two values on the x-axis? So in this case, it's given to us very obviously is x equal to 1 and x equal to 8. So right here I have x equal to 1 and x equal to 8. Okay, so I'm going to write this integrand as a definite integral. So v equal to pi times the integral evaluate from 1 to 8 of 9 divided by x all of it squared times dx. So at this point, you see that it's very clear for you to integrate and then use the fundamental theorem to figure out the actual values, because you are having the upper limit and the lower limit. And it's so obvious right here, right? So your cross-section area is around here, and then you keep revolving it around the x-axis, and you form the solid, and you going to use this method. So now in this case, all you have to do is integrate. So let's continue with that. I will do it on the next page, but on the next page I kind of show everyone the 3D figure of this solid. So right here we are talking about this part, right? So let me be consistent with my colors. So right here I have this. All right. Okay. Then here's my element perpendicular to my axis of rotation, and the area, this area I'm talking about is this one. Okay. So in 3D it looks like this. This is my y equal to 9 over x. Okay, so right here is x equal to 8, and right here is x equal to 1. Okay, so I actually using AutoCAD and drew this. Okay, I using AutoCAD and drew this for everyone. And in here, the 3D, if you rotate it a bit, you see that it looks like a horn, right? Anyway, using Mastercam is to create this 3D image for everyone. So let's continue and calculate our solid. So let me write everything again. X equal to 1 and x equal to 8 as given, right? Okay, so v equal to pi a to b y squared dx. So this is the formula that we have to use. That means I multiply this with pi 1 8 9 over x all of it squared dx. So now you know that this is application that we have to deal with, right? So that means you have to, at this point, you don't want to make any error with this. You need to know how to integrate and apply fundamental theorem to figure out the volume. So we can quickly review that. Okay, I will not skip any step here. I will still going over how to integrate and apply the fundamental theorem, upper limit minus the lower limit, to figure out the volume. Okay, so this is what we are going to do. All right, so from here, I'm going to draw the arrow here for everyone to see. So what I'm going to do is I will just write the pi, and this is 1 2 8, and 9 over x all of it square. What you want to do is you want to square this numerator and denominator. So don't forget the formulas is a over b all of it to the exponent n. Then you need to raise the numerator to the exponent n, and you raise the denominator to the exponent n. So in this case I will have 81 over x squared dx, right? Okay, so now 81 is a constant, so I'm going to bring that across the integral sign. So 81 multiplied by, so let's not skip any step, 81 multiplied by pi 1 over 8. I will write it as 81 multiplied by 1 over x squared times dx. Alright, okay, so I'm going to bring this 81 across the integral sign. So I will have 81 pi 1 to 8 x to the minus 2 dx. Okay, you raise this to the exponent other than minus 1, then you can raise it to this certain exponent, and from this exponent you can apply the method of integrate. So that means I will have to take the exponent, add 1 divided by the result. Okay, so over here I should get it as 81 pi multiplied by the integral from 1 over 8. But I am going to integrate now. I'm going to integrate, so I'm going to take this integral sign off. Alright, so make sure that I'm going to integrate, so no more integral sign. So it means that you take minus 2, right? You minus 2 plus 1, isn't that minus 1? You divide it by the result. Therefore, I will write it like this. 81 pi, I will multiply by 1 divided by minus 1 times x to the minus 1. Close this, then write this line from 1 to 8 because I have to evaluate this in term of FB minus FA. Apply the fundamental theorem. So before I apply fundamental theorem, I'm going to simplify what I have inside this bracket. So I will have 81 pi multiplied by x to the exponent minus 1 from 1 to 8. I will bring this minus, I will take this minus and I multiply by 81, or in the ways that I take 81 pi divided by minus 1. So divided by minus 1 or multiplied by minus 1 is the same thing. You know that, right? Because it's the magic number 1. So we'll turn this into a minus of 81 pi. Okay? So now you get that. This minus 1, I will do the operation like take 81 pi divided by minus 1. I got minus 81 pi. And then all I have to do here is just have the x to the minus 1, evaluate from 1 to 8. So at this point, I'm going to write this like this. Alright, I'm going to write it as minus 81 pi multiplied by the fundamental theorem that I have to apply. So I have to multiply by f of a minus f of minus 1. That means you are going to raise this a to the exponent minus 1 and this minus, so why do I write minus 1 here? It will be just the f of 1, okay? So your x in this case will be 8 and your x in this case will be 1. Okay, so then it will be equal to minus 81 pi multiplied by a to the exponent minus 1, subtract 1 to the exponent minus 1, and close this. Apply the fundamental theorem of calculus. Okay, so maybe I should write it like this for everyone to realize that I apply the fundamental theorem here. Okay, so now I will have minus 81 pi. So what is a to the minus 1 is 1 over 8. What is 1 to the exponent minus 1 is just 1. So take this, subtract this. What do I get? So inside the bracket, I should have minus 7 over 8. Okay, so 1 over 8 minus 8 over 8 equal to minus 7 over 8. Okay, so I have 7 over 8. Now you see this negative multiply with that negative will give me a positive result. Then what do I get? I get 567 over 8 times pi, and the unit should be unit Q. Okay, so I recommend that everyone just leave the pi and just give me the answer like this. Okay, so therefore the volume of this shape could be equal to 567 over 8 pi unit Q. Okay, so this answer is the exact answer. Okay, the exact answer. You don't have to divide it by 8 and multiply by pi and give me a decimal number. So this number is good here. All right, okay. So let's start with example number 2. Okay, so then in the process, it will review again. I will have to repeat how to integrate. I will have to repeat how to figure out the result and then apply the fundamental theorem. All right, okay, so let's start with example number 2. So example number 2, I would like to talk about finding the volume of a solid, and the axis of rotation is the y-axis. So for us to continue with this, I'm going to briefly show everyone that the best is to draw the diagram. So the y-axis, this one, is that right? Is your axis of rotation. Okay, so they give us here. So you rotate around the y-axis. And this method means that the element has to be perpendicular to the axis of rotation. So you are going to draw the elements that perpendicular to your axis of rotation. Therefore here, so in this case, what do you use? It is dy, because it's a horizontal element. Okay, so keep that in mind, because if the horizontal element then is also obey this rule. This method is about perpendicular. So in this case, what do you use? You are using these formulas right here. Okay, see the dy. Here is your differential factor of dy. And what is the x squared? X, that means this is the function in term of y. And when you have in term of y, what is the lower and upper limit? The upper limit associated with your y-axis. Therefore, it's a c to the d. Okay, so again, I put it here for everyone. X is a function in terms of y. Axis of rotation is the y-axis. It is a horizontal element which used, and the cross-section area is the horizontal disk as shown below. So let me quickly draw the through this. This is your x and y axis. So this is the x, this is the y, and you rotate about the y-axis here, and then you are talking about the horizontal element. So this is my horizontal element right here. Okay. All right. So in this case, we are going to work with these formulas. So let's talk about this example. Okay. This example said that use this method, find the volume of the solid generated by the area bounded by the given curves. So y equal to the square root of x minus 3, and then y equal to 4, y equal to 2, x equal to 0. Axis of rotation is the y-axis. So each time that you have to find the volume of a solid generated by certain area, then it always give you all of this function to work with, unless they ask you to find the upper and the lower limit. Okay, so but this particular example is giving us y equal to 4, y equal to 2, and x equal to 0. Then what we need to do is we need to identify all that. Okay, so what is x equal to 0? X equal to 0 is the y-axis. So this is the x equal to 0 here, but I need to draw this to show everyone that the axis of the rotation is the y-axis. So that means I need to use horizontal element, and this is the y-axis, this is perpendicular, and this is the dy. Okay, the shape is this. Now this is the y equal to 4. This is the y equal to 2. Okay, and y equal to the square root of x minus 3. If you have a square root, that means you have a parabola opens to the side. And the parabola is open to the side, is this one. Okay, so then what is the area that I have to work with? This is the area. Okay, so highlighting the area is very important. Okay, and then what is my element? Element perpendicular to the axis of rotation. So in this case, I should have the horizontal element of dy. So here is my dy and perpendicular to the axis of rotation. So that means it will rotate over to this side. It will rotate the exact same over to this side of the y-axis. Okay, it rotate over to this side of the y-axis. So let me show everyone the solid. I took the picture and I put it right here. Okay, so this is the previous example. Okay, I will post this as well for everyone. So here it is. So here's my example number 2. So let me draw this for everyone. So if I go exactly um, like this, this is the y-axis, and this is the y equal to 2 here. Okay, so this is y equal to 2, and then the x-axis is somewhere around down here. So let me draw this y equal to 2, then the x-axis is here. Okay, so here's the x, here's the y, and up here is my y equal to 4. So let me change the colors. I will use purple. Is that purple? Yeah, it is purple. And right here, so y equal to 4. So this part is my y equal to the square root of x minus 3. And then this part here is x equal to 0. Exactly what they are given to me, right? So y equal to the square root of x minus 3, y equal to 4, y equal to 2, and x equal to 0. The area I'm talking about is this area. Here is my horizontal element perpendicular to the axis of rotation, and you rotate this one about the y-axis. So when you rotate this area over to the side, you are having the exact same area like this. Okay, so this is the exact same area that you rotate about the y-axis. Okay, so what does that shape looks like? Okay, so this is the same thing again, and here's the shape. This is the shape right here. Okay, so this is half of the shape. This is the entire shape. I put it upside down so everyone can see this is the circular disc that we are talking about here. Rotate about the y-axis. So right here, if you imagine the 3D, it should go through here, right? Okay, so this is your y-axis and rotate about that. And let me see if I take any more picture. No, I don't take any more picture. And you see, this is rotate about the y-axis, and the circular disc keep continue on and rotate about the y-axis. And for us to have this shape, we have to work with this area. Okay, so I have 6 more minutes left. So I just have to, I may have to have another video for this because honestly, I don't want to rush. Okay, if I rush, I may make an error. And also, if I rush, I will be skipping some steps. So I don't want to do that. Okay, so make sure that we are going to identify the formulas that we are going to use. Okay, so the formulas given to me in this case is this formulas. So let's write it down. Alright, okay. So is volume equal to pi c2d of x squared times dy. Okay, so keep that in mind. Okay, so v equal to pi c2d of x squared dy. Okay, so what is x squared? X squared means that you must have a function in terms of y because you are using dy. Okay, so in this case, what you need to do is, because you are given y equal to x minus 3. Okay, y equal to x minus 3, the square root of this, it means that you are working with a function y, but it's in terms of x. So you need to identify this one as, you need to rearrange this so you have the function in terms of y. So for you to have in terms of y, that means you have to solve for x. Okay, so I'm going to square both sides. Okay, square both sides so I can open the x, and I'm going to solve for x. So in this case, square both sides, I have y squared equal to x minus 3. Okay, square root of this, and I square that, I will get rid of the square root. So now I will have y squared plus 3, okay, equal to x squared. Equal to x. I'm sorry, equal to x. So the formula said that I need to have x squared. So why don't we square x right here? That means I square this side. Okay, I was trying to be ahead of myself. So this is what I have. Okay, so let's zoom back. I just want to explain one more time. Again, I don't want to rush. I will do another video just to integrate this for everyone. Okay, so now I have v equal to pi times the integral from c to d of y squared times dy. So dy telling me that I have the solid rotated about the y-axis, and my element is the horizontal element, which is perpendicular to the x-axis like we have up here. Okay, so what does that mean? It means that my function has to be in terms of y, but given to me as y equal to x minus 3, so this particular function itself, then I say this one as in terms of x, because y is isolated on this side. When y isolated and x is on this side, then this is called in terms of x. But I need to have an in terms of y, therefore I have to solve for x. In terms of y means that you have to isolate the x. Then you end up with a function in terms of y. So to isolate this x, I need to square both sides. That means isolate x means you have to solve for x, okay? So I square this side of the equation, I square this side of the equation as well. Then I have y squared equal to, if you square root something and you square that, you cancel this 2 out, okay? So if I want to explain this a little further for everyone, what is the exponent of square root? Okay, so x minus 3, let me write this one as, okay, I have room here. I will write it like this. Y square equal to the square root of x minus 3, all of it square. Okay, so why does it become just x minus 3? Because this one is x minus 3. Convert that to the exponent a half because of the square root. All of this square, right? Isn't that you have to take a half multiplied by 2? So x minus 3 a half multiplied by 2. So this cancel out. So you should have x minus 3 all of it to exponent 1. So in this case, if you have a square root,